Fatty acids vary in length according to how many carbons they're holding. And it's also important to note that it's not just how many carbons they're holding, but the locations of those double bonds. In a saturated fatty acid, the carbons have the maximum number of hydrogens that can be attached to those carbons, and there's absolutely no double bonds. In unsaturated fatty acids, they have one or more double bonds. And you may have heard that term. It's an unsaturated fat or it's a saturated fat. Saturated fats are the ones that can cause heart disease. Unsaturated fats have got a double bond. Now, what that double bond does is it knocks off two hydrogens, so it's unsaturated. If there is just one double bond in the fatty acid chain, it's called monounsaturated. And if there is more than one, it's called polyunsaturated. Our bodies have a hard time storing polyunsaturated fats because that double bond gives the molecule a kink and it's not so linear. And because of that, it's harder to store. We can escort that type of fat out of our system. And those are the kinds of fats that actually help us because we do have to have fat. It's one of the group of macromolecules that we have to eat. It's sort of like putting a little coal on the fire. We're not going to burn up our food, and our metabolism isn't going to work properly unless we give it a little fuel. Now this picture shows you on the left a saturated fat. Saturated fats are solid at room temperature, so you can think of butter, bacon grease, animal fat, the fat on your steak, that kind of thing. That's the kind of fat that can be problematic if we have it over time. It can build up, and if we have a lot of it, it can cause heart disease. So here's a structural formula, and you can see this has got 3 fatty acid chains, so it's a triglyceride, and all of those carbons are loaded with hydrogens. And then, of course, this is your space-filling molecule. This particular one is called stearic acid. On the right are unsaturated fats. If you notice down here, it has a double bond. So this would be a monounsaturated because it has one double bond. And because of that, it gives a kind of kink. When they draw it, it looks like your leg is kind of poking out here. The space-filling molecule, this is oleic acid. Excuse me, it's unsaturated. And the double bond causes this saturated fatty acid to bend. Now this is in the cis position, so it's bending towards us, which is always cis.